In this section, we'll dive into two critical topics: kernel panics and device types in the /dev directory. Both concepts are fundamental to Linux system management and troubleshooting, as they involve understanding how the kernel interacts with hardware and handles errors. A kernel panic is a critical system error that occurs when the Linux kernel encounters an issue it cannot recover from. When the kernel panics, it usually halts the system and a crash screen is displayed. Understanding kernel panics is crucial because it helps you diagnose severe system errors, especially in production environments. Causes of kernel panic: hardware failures, faulty memory, RAM, defective storage devices, or CPU malfunctions. Corrupted or missing kernel modules: when essential drivers or modules are corrupted or improperly loaded. Kernel misconfiguration: if a newly compiled kernel is improperly configured or incompatible with hardware. Faulty or incompatible device drivers: incorrect drivers, especially after a kernel update. Memory or resource exhaustion: when the system runs out of memory or faces resource contention. Typical kernel panic screen: you will see a screen filled with technical details about the kernel state, including error codes, memory addresses, and stack traces. This information is helpful for diagnosing the root cause of the panic. Steps to handle kernel panic: reboot into an older kernel. If you have multiple kernel versions installed, you can boot into a previous version using the grub menu. Check logs. Logs are critical for troubleshooting. After rebooting, check the log files, especially /var/log/messages or /var/log/syslog, to identify the cause of the kernel panic. Example: less /var/log/syslog. Rebuild the initramps. If kernel modules are missing or corrupted, try rebuilding the initramps using Kernel or Drakit. Test hardware. Run hardware diagnostics to check for faulty components, RAM, disk drives, etc. Tools like Memtest86 can help diagnose faulty memory. Check kernel updates. Ensure that kernel updates are properly applied, and check if any recent updates might be causing compatibility issues. Device types in /dev. The /dev directory contains special files, known as device files, that represent hardware devices connected to the system. Linux treats everything, including hardware devices, as files, and /dev is the interface between the kernel and these hardware devices. Device files allow user space applications to interact with hardware. There are different types of devices categorized based on how they interact with the system. Block devices. Block devices are devices that read and write data in fixed-size blocks. These devices handle storage media such as hard drives, USB drives, and CD-ROMs. The most common block devices include storage devices, where data is stored in chunks, allowing random access. Examples of block devices: /dev/sd represents the first hard drive, SATA drive, on the system. /dev/sdb represents the second SATA hard drive. /dev/loop0 represents a loopback device used to mount files as block devices. Usage: block devices are accessed for reading and writing files and are crucial for managing file systems. You can list block devices using the lsblk command. This will display all the block devices connected to the system, including their partitions and mount points. Character devices. Character devices are devices that handle data one character at a time. These devices are typically associated with input-output operations like keyboards, serial ports, and mice. Unlike block devices, character devices do not buffer data. They process it in a continuous stream. Examples of character devices: /dev/tty represents terminal devices, physical and virtual terminals. /dev/console, the system console, used for system messages and input during boot. /dev/ttys0 represents a serial port. Usage: character devices are used for devices that require fast, unbuffered communication. You can list character devices using the ls/dev command and look for devices marked with AC for character device. Special character devices. Some devices in the /dev directory are special character devices used to generate or discard data. These special files are useful for various administrative and development tasks. Common special character devices. /dev/null. Known as the bit bucket, anything written to /dev/null is discarded. It's often used when you want to ignore output from commands. Example, redirecting unwanted output to /dev/null. ls/nonexistent_directory 2 /dev/null. In this case, the error message, 2 is the file descriptor for error, is discarded by sending it to /dev/null. /dev/0. This special file generates an infinite stream of 0 bytes when read. It's often used for creating empty files or overwriting data with zeros. Example, creating an empty file with 1 megabyte of zeros. dd if equals /dev/0 of equals empty file bs equals 1 m count equals 1. This command uses dd to copy 1 megabyte of zeros from /dev/0 into a file called empty file. /dev/urandom. This is a pseudo-random number generator that produces random data used in cryptographic operations and seeding randomness in applications. Example, generating a random key or password. Head C16/dev/urandom base 64. This reads 16 random bytes from /dev/urandom and encodes them in base 64, which can be useful for creating cryptographic keys. Mastering device types in the /dev directory and understanding kernel panics are essential skills for a Linux administrator. By learning how Linux interacts with hardware and how to handle critical errors like kernel panics, you become better equipped to manage and troubleshoot Linux systems effectively.